So yesterday you did an activity to show you what happens when you change the slope or the y-intercept in an equation or a line. Today we're going to go over those things in a little more detail so you can actually understand what it is that happens in these situations. We're going to start with the slope. You can see there on the screen that I have y equals x or y equals 1x graphed for you, where the slope is 1. Yesterday, hopefully you realized that as the slope gets smaller, like it becomes a fraction, 1/2, 1/3, 1/4, 1/5, something smaller than 1, something that would give you a decimal, that the line gets flatter. So the closer the slope gets to 0, the flatter the line gets. An example of this would be if we did y equals 1/3 x. You can see that the new line that just popped up is more flat. It's closer to the x-axis. If we do another one, something that would be even smaller, like let's say 0.1x, that's pretty close to 0.1. And you can see that the new line has gotten even more flat, almost even with the x-axis. So the smaller the slope number gets, the flatter the line will be. On the other hand, the bigger the slope gets, the more steep the line will be. All right, we're getting closer to where it would be going straight up and down or a vertical line. So I'm going to multiply this original slope of 1 by 3 and get y equals 3x. And you can see how the line is more slanted. It's more steep. It's going up faster. And this will continue to happen as the number, the m number, continues to get bigger. If I make it 7x, you can see it becomes even more steep, and as the numbers get bigger, it's going to get more and more closer to becoming a vertical line. With the slope, making the slope negative is going to flip or reflect the line across the y-axis. So right here I have y equals x graphed. I'm just going to make it y equals negative x. And you can see how it's kind of flipped. It's like a mirror image over the y-axis of what happened, of the first line. This happens with other lines too, so you're not always going to have one going through the origin. For example, let's make the first one x plus 5, and then I'm going to make the bottom one negative x plus 5. And you can see that it's the same line, just sort of reflecting from each other. So it's like looking in a mirror. So putting a negative in front of the slope makes it have a reflection over the y-axis. So we talked about what happens when we change the slope. The smaller the slope gets, the closer it becomes to a flat line, or the flatter it gets. The bigger the slope is, the more slanted or steep the line is. Whenever we put a negative for the slope, it makes it reflect over the y-axis. So it sort of flips the line. Now we're going to talk about what happens with the y-intercept. So as you can see here, we're starting again with just y equals x, which means that our b number, or our y-intercept, is 0 right now. So I'm just going to add a number to that. Let's just add 4. So I add 4, and you can see that our new line is parallel with our original line. This new line has done nothing but just slide up. It started here, and all these points just slided up 4 units because we added 4 to the y-intercept. So we turned this point right here, and we moved it up to here, and it just made everything slide up 4. So changing the y-intercept or the b number will make the line slide up or down that many units, depending on if we're adding or subtracting. If we add, it slides up. If we subtract, it moves down. Let me show you an example of moving down. Let's add, let me subtract 5. So now you can see because our y-intercept is at -5, that it went down 5 units from the original point at the origin. So changing the b number just moves the line up and down the y-axis. I'm going to take away that original equation and show you that if you have an example like this, where it's going to ask you how many units did the line shift down. Well, if you start with y equals x plus 4, it shifted down 9 units. You had to go down to 3, 2, 1, 0, -1, -2, -3, -4, -5. That's going down 9 units. All right. How lines shift going up and down always depends on the y-intercept. You're just looking at where it touches the y-axis, because lines are not always going to be slanted the same way. They're not always going to be parallel. You can have an example like this. And it's asking you how many units did this line shift down? Well, starting here at 2, you went down to 1, 0, -1, -2, -3. You went down 5 units. Doesn't matter that these lines are crossing over here or that they've gotten super far apart on either side. You just count down the y-intercept to determine how much they've shifted. So, one more time to recap. The closer the slope gets to 0, the flatter the line gets. The bigger the slope gets, the more steep the line will be. A negative slope makes it flip or reflect across the y-axis. Increasing the y-intercept or the b number will make the line shift up that many units, and decreasing the y-intercept will make the line shift down that many units.